Hello everybody, welcome to this channel. This is Vivek along with my team presenting this video. So this is part 4 of this business intelligence series, and today we are going to discuss about the data pipelines which are responsible in providing the data to the business intelligence systems. We all know BI systems primarily work on data within the organizations, and this data is generated by different data sources and reside in various systems. So one of the primary responsibility of BI system is to bring all the data into one common place, data warehouse, and make it available for the BI systems or the visualization tools to work on it. So now let's discuss what's the data pipeline and how it helps the BI systems. So on a very high level definition, data pipelines are a set of programs which performs the data movement from different data sources to a target. Let's see the architecture of a data pipeline. The architecture involves a connector to the source systems followed by a series of processing units embedded in one pipeline. Within the pipeline, these processing units can be configured to run either sequentially or parallelly based on our needs. So in our picture, processing unit 1, 2, 3 runs sequentially. That is, the output of first processing unit goes to second, and the output of second goes to the input to third processing unit. Finally, the output of third unit combined with the output of fourth unit and goes to the service layer. The service layer is the data warehouse. So here processor 4 and 1 starts at the same time and performs the job parallelly. So next, within each processing unit, there could be one functionality or multiple functionalities embedded based on the need of the data extraction. So in normal scenario, as a best practice, we normally embed a single functionality in one processing unit. So this helps for easy debugging. So the final output goes to service layer. Service layer is nothing but the data warehouse from where we start building our reports. So these pipelines are built using Java or Python. So even though we represent this architecture in the pictorial matter, but in reality it is a single Java or Python program which has separate routines for performing each functionalities. Now let's discuss the various types of pipelines available. The very first type of data pipeline is the batch mode, which is most common. In this, the data is processed sequentially and in batch mode. So in this type of pipelines, we connect to a data source systems which already has a data. And these data is extracted in batch mode. When you say batch mode means we extract for every run we just pull 10,000 records or 20,000 records and process sequentially, and this data flows in through the processors 1, 2 and 3 sequentially, and each processor performs some functionalities before it is sent to the next processing units. These kind of pipelines are used for readily available data which is already generated and stored in a particular place. For example, a file systems which is already generated and stored in a folder, or a relational database which contains the data. So in these scenarios, this batch mode is well suited and performs well. For example, if you want to extract a student registration information from a student database, so in that case we normally use batch mode. So let's see the next type. The next category would be the real-time data or the streaming data pipeline, which extracts the data from these source systems directly. So normally how it works is a system generates data and it is stored into a database or a file. But in the streaming architecture, when the source generates the data, it is directly connected to our pipelines. So it is not stored in any physical media. The data is directly sent to the pipelines. So it's kind of live data. And this method involves a cost in performing the data extractions. So normally softwares like Spark is used to build these pipelines. So as an example, if you want to extract some data from some manufacturing assembly line, means it is a live data. So as the part moves from one station to another station, the data is generated at each station. We need to extract quickly and put our data into the analytical platform to see the live results. And then for example, if you want to analyze the video film like a Netflix or a HBO who does analysis on the streaming data, so in these scenarios we will be building this streaming data pipelines. The next type is the Lambda category. So in this category we use the advantage of both the batch mode and the streaming mode in a combined manner. So we use both batch mode and streaming mode in one single data pipeline. So in that case, at the same time we can extract data from a static data sources like tables, and we can connect to the streaming applications and get the data, and we can process both the data in one single pipeline. So these analytics are performed by organizations like Netflix and HBOs. They collect the static data like customer data from static tables, and they collect the streaming data, what films or seasons they are watching. So they combine both the data and load it to a table for analysis. Based on the organization need, we choose which type of pipeline is required for data extractions. So prior to this data pipelines, what we are doing for our B systems is we are using a traditional ETL system. That is extract, transform and load. These were performed by tools like Informatica and Alteryx. So these tools were used a little earlier before the data pipelines technology came in. The only disadvantage of the traditional or the earlier method was those work only on the batch data. We can extract data only from the static systems and load it into the warehouse. Those systems were not able to perform well on the live data or the streaming data. Even today, we use ETL within our data pipelines, but we use ETL as a sub-process embedded within the pipeline. So now let's discuss about the characteristics of the data pipelines. So basically a data pipeline should be continuous functioning system. So whenever it finds the data in the source systems or the connected systems, it should directly pull the data, provide the data to the processing units and send the processed data to the target systems. And it should be scalable. So whenever we have a less data, it should work on the less data. If the data is increased enormously, it should still work on the large data to perform the same functionalities what it did for the smaller data and send the data to the target systems. Then it should be independent of the resources. When we say independent, it is the performance of the data pipelines is not dependent on any surrounding systems like source systems or target systems. It's maybe dependent a little bit on the quantity of the data, on the processing time it takes. Otherwise, data pipelines are independent. Now let's discuss about the benefits of the data pipelines. So we saw that data moves from one processing to another processing unit within the data pipelines. So we have the flexibility of monitoring the data, how it flows from one processing unit to another processing unit. This helps to get the quality data for our target systems. Next is data pipelines helps us to provide incremental load. So since it has a characteristic of continuous processing, so once the data pipelines are set up, they start monitoring the source systems. Whenever they get the new data, they perform the extraction process and load it into target systems. And next benefit is reusability. Most upstream data pipelines are configured generically, like by changing a source and a target, we can reuse the data pipeline for different sources. So with this, we are coming to the end of this video. Please let us know if you have any questions on these areas in the comment sections. We will be happy to help you. Thank you.